All right, cool. Well, I'll introduce myself. My name is Andrew Obergewich. I'm a senior software engineer at LexisNexis. I'm in charge of, basically, we have a lot of data. We're the second largest data broker in the world behind Google. And so we have to manage that data. And so I build dashboards and ways to manage the data, basically. And we have a lot of government, it's government-focused business, government, legal, that kind of stuff. So we focus on lawyers, governments, law, patents, trademarks, all that kind of stuff. And so we literally track every law and patent and trademark in existence. Yeah, so that's basically it. So I use GraphQL to help manage this data. We're basically creating a bunch of GraphQL APIs for different data sets and creating a reusable React interface that can, because GraphQL can be uniform in the way it outputs data, which allows us to basically have components that can take any GraphQL data and generate different types of dashboards and ways to manage it, auto-generate forms and all kinds of stuff like that. So let's get into GraphQL here. So first of all, it's a graph, obviously, GraphQL, graph query language. So the first thing is, what is a graph? Why, how does that relate? So GraphQL is based off of graph theory, which you would learn, I don't know, general, computer science math, stuff like that, where you have, it's using a lot of algorithms, as well as data structures such as different trees and stuff like that. But the concept, obviously, you have nodes, A, B, C, D. You have edges, which are things that connect those nodes. GraphQL is basically a directional graph, which you can have it go only one way if you want. So you could have A is connected to B, but B doesn't have a connection back to A, for example. The way you define your schemas in that. So it is a directional graph, and you can modify it. Like you could have A as a collection, a many-to-one relationship. A has many B's, or has an array of B's, but B is only connected to one A. So there's just a lot of different ways of defining the edges. And then it also is an API. The thing is, when you have like typical REST API, you'd have your database, and they hit some kind of REST endpoint, usually send an ID, like get product, in this case get products 1, 2, 3. So returns ID of the product 1, 2, 3. But there's issues with REST. It's called like overfetching, underfetching. You get too much data, not enough data. For example, if you just want to return, say, it's an e-commerce website, and you just want to return a picture and the name of a product for your homepage. But now you got everything about the product on your homepage, the descriptions and everything. Or you want to get, let's say, another example is, you have, say, Facebook is a good example. Say you want to return a user, and this is an example of underfetching. You want to get a user, but you also want to get all the groups they're in and their family members, for example. Well, you got to do one API call to get the user. Then from that user, you then do another API call to get his friends, and then you do another API call to get his groups. And so it's 3 API calls. And you can imagine if there's, you're dealing with 100 different instances or something like that, all of a sudden you're writing 4 or 5 API calls for every thing you want to get. It becomes like a nightmare to maintain, and yeah, it just becomes a mess. And then there's also issues with REST, versioning, maintenance, things like that. You update the REST API, and maybe some route slightly changes, and now you got to track what version you're using, because you hit the endpoint and it doesn't return what you want. You got to, hit endpoint version 2, not version 3. And some people might be using, like you have an external facing API, they could be using your API. You update it, but you have to keep 2 versions now, because people may not have updated their code. If you change it, they're going to be upset. So you have usually, especially in the day of these days of cloud computing, you have API gateways. which is I'm using work with AWS. There's an API gateway, and basically it's an interface. It's like a connection between the back end and the front end code. Or the back end, it generates the route and then executes some code which is connected at the other end separately. So, you know, you have your mobile, your desktop, that kind of stuff. So GraphQL obviously will be needed. In your API gateways, you're going to have also multiple services potentially. Like if you have a well, let's just say you have some kind of service, some kind of data service, and you've got weather data, you've got, say, stores, and you've got Google Maps. And so now you want to, you know, integrate that into one cohesive picture, except you've got to do API calls for all three services to be able to get the data, and you've got to first do one call, get the data off of that call, and then do another call and figure out how to interrelate them all and all this kind of stuff. And there's no real relationship except for what you write in your code. And once again, you're talking about, you got to put a lot of logic there to say, oh, I want to get the weather's data for Macy's and Roseville. So now we got to get that Macy's by ID, and then you find out what city it's in. Then you send that data to Google Maps, get the map, and you send that data to the weather thing, and, you know, aggregate it all together. So GraphQL differs in many ways where, and this is like very simplified thing here, but GraphQL API basically looks very similar in this case, but same thing. You have a client, you do a query, you get data back, right? But there's only one endpoint, and it's GraphQL. That's the endpoint. You don't have to hit, like in REST, you have to hit multiple endpoints. So you don't have to even you don't have to know say user endpoint, product endpoint, address endpoint, stuff like that. You don't have to track that anymore. It's just one endpoint. And this is the issue I was talking about, where you're using multiple services. So you could have in this case, there's a whole bunch of services where you have a product, a payment, user, inventory. So you might have, in this case, 4 different GraphQL APIs. Well, those can all be combined into one GraphQL endpoint at the API gateway. So now you just have one endpoint, and the endpoint, you say GraphQL query on product, on payment, on user, and it's all contained within one endpoint. You don't have to worry about all that kind of stuff. Plus, you can include REST services, like they've got a shipping service. In this example I found online, I don't even know what a basket service is, but shipping notifications. So you might have like UPS, FedEx, REST API. So now when you you can create a relationship in GraphQL, basically a synthetic relationship where you can match the shipping service to a sale. Like you might have a sale object, and you can say, okay, each sale contains a shipping node or shipping edge that connects to a shipping data, basically, and there's the address, blah, 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 and their UPS tracking number. And that would execute the shipping and REST, return the tracking number, and match it up. As far as the API is concerned, you would just see it all as one cohesive thing stuck together. Same with the notifications. You might have an email service or something like that sends out emails when it gets shipped, but you could also do things with that as a connected object. I'll show you when we actually get into doing some queries and stuff, how that works. So a little history. GraphQL is made by Facebook in 2012, released publicly in 2015. It's a specification. It's not like a library or anything like that. So it's specification, and people are free to implement it as they choose. So there's many different libraries, and it can be implemented in many different languages. So it's not just React. There's a Python, there's a C, I believe there's a C#. There's obviously Apollo, which Apollo is probably the top one right now. Java is built up for Node. It'll work with, it doesn't matter. It's a backend Node service, so works with anything that hits that endpoint. And here's an example of a query and response. So you have a query. I'll just walk through it real quick. So get data, right? That's your name of your query. So you have, that's supposed to be a money symbol there, not a pound symbol. But so a money symbol in front of it, that is specifying that is variable, basically. And it's strictly typed language as well. So you'd have to, so it's an int, and exclamation point means it's required. So this is saying it has to be an int, It will fail if you don't pass an int into it, and it is required. If you don't send that data in, the query will fail, and it'll return an error message. So you pass in like a number, 1, 2, 3 or something. In this case, limit means, this is actually a limit is how many. This is a common GraphQL thing too, where limit is just how much data is allowed to be passed back. Like you can say 100 to give you 100 things back, or 2. So then this is the actual query. It's kind of like I guess you call it a wrapping function, basically. So it gets wrapped in a function, then the query is actually inside here, and now you have the limit, and you're passing that variable, which is a limit, and then it returns edges, which is an array of nodes, is usual format. So, and then you're specifying the shape of the return, like we have ID and description. So then it's going to return data, edges. Well, it's missing a little part here, but I took it out because it didn't have enough space, but it really would say get data, and then it'd be another section here, get data, then edges, then node, and then you have each node contains the data in the edges. And so now we're going to actually go to a GraphQL thing. Here's the Star Wars GraphQL implementation, and this interface is called Graphical. It's just a standard library you can manipulate GraphQL with. First things to know, there's a variables field, there's a queries or an area here where this is where input goes, and then you see here that it says docs. If you click on that, it provides, GraphQL is basically outputs a schema. So it's a self-documenting API. You don't have to write documentation and saying, here's every endpoint you can hit. Here's how you use them, as you do with REST. It's right here, that's it. And you don't have to write that. So that's one big benefit. The other thing is, though, which I've used at work, see how it says there's a query. If you click on it, now it lists all the queries. So at work, I have some forms and stuff like that we have to do. So what I did, and we have a lot of data, like I was saying, and so we have a lot, like we have hundreds and hundreds of possible queries and mutations and things like that. So what I did is I just basically set it up. I would read the schemas, because you can get the schemas, and as you see, it's returning the schemas here. So you get them, and all I do is I take the schema, I have it search for the name of the query mutation, and then it generates a form based on the schema. And it just says like the name of the input, and if it's a string, it's a text. If it's an int, it's a number. So literally just it just reads the schemas and auto-generates forms, and they exactly match. So if you change the API, even you don't have to update your front end; it just changes. So let's show you a query real quick. So let's just do all films. Oh, sorry. So the simple way, which you actually want to use this in production, but I'm just going to show you the simple way first, is, so you want to get all films, right? So I'm sure there's probably edges. You can actually find out, so you see the schema here, so it says films connection, so that's basically a node. So then you look in here, it says page info, edges, total count, films. So I'll just add total count just because that's always fun to have. Films, I'll see what I can do with that. It says array of film. Anyway, so then and then there's this page info. That's like for tracking where you're at. Like if you put this in, you can say start cursor, end cursor, has next page, has previous page. So this is like, say you have 1 million documents and you want to retrieve the first 500. So that you can say, okay, so it starts here, ends here. It's for like pagination. Then you want to get the next 500, next 500. So you just have your start cursor, end cursor, so you know, like, where the data is currently sitting. Then you're gonna have, so your edges, and you're gonna have a node. There's always a node inside the edges. There's usually a cursor in here too. Let's see, yep, exists. So that tells you exactly where you're at in the data set, which the server provides all this cursor tracking data. It just gives you strings and it matches them up on its end. There's probably an ID, title, and you can also see all that data too. If you go in here, see node, and then film. So film is a data type. and you go in there, it's got title, ID, episode ID, director, sure, why not? And we'll do that one for now, keep it simple. All right, so that returns, so you got data, all films, then we got page info, which start cursor, end cursor, has next, has previous, so this give me everything. So there's no next, no previous. Then the edges, so, and then individual nodes. So we have A New Hope, Episode 4, George Lucas. Empire Strikes Back. Director is Irvin Kershner. And then we have Return of the Jedi. Director Richard Marquand. And then we have The Phantom Menace. You know, all this, basically all the movies here. And then we get down to films. Oh, it looks like films provides an array of all the IDs. All right, fine. I didn't know what that was, but I don't know that. Oh, it's not just so films is an array of all the movies. Not, I don't know the purpose of that, but just get rid of it. All right. So then, so now what if we want to go down? I don't know. What if we want to see how this has sub data here? Species connection, starship connection. Now these are actually edges to other collections of data. I'll show you real quick here how this works. So say we got a starship connection. Now that will also have edges. It'll also have nodes. And it'll probably have some kind of name. And all right, so we got, let's just do that real quick. All right, so now we got all the ships. So now we got every movie and all the ships in every movie. But what's cool here, let me just show you how you can pass in. So let's get a little more complicated here. So let's say we want, let's do a limit. It was not going to, wow. Okay, it's not going to let me do a limit probably because there's only a few of them. But so I'll say give me the first 3 movies. See if that works. Oh yeah, let's get even more complicated here because we won't be able to tell anything. So give me the first 3 ships for each movie. And see, I'm doing queries. Like basically, it lets me query up here. You can do queries, but then Starship connection actually, same as all films, has a query function. Starships also has a query function, which if we go back up here, so all starships right here. So the starship connection is actually executing this all starships function inside. So it's like a function and a function. So I can say, give me the first 3, and then give me the first, I don't know, say 4. Give me the first 4 starships. So now we got, see 4 starships there, and then we got the first 3 movies, I'm sure. So you up to Return of the Jedi, and then 4 starships. But we'll get what's even deeper in this. Let me go to the starship connection. So I want to do something here. So we get deeper into this, and say we want to find out. Actually, I want to get an individual film. Give me so all films, all people, all starships, all vehicles. I want. Oh, this one's like a subset. It's not even let me search for individual films. That kind of sucks. Oh well. I was going to do something here, but I can't. Oh, here we go. Film. So it's just called film. All right, I'm going to change that to film. And then we're going to search for, I'm just going to go by this first film here. Let's see. Film ID or ID? Not sure what the difference is between those, but I'll just try like this. I think it wants double quotes. Yeah, let's try. Films. Oh yeah. So, all right. So it's not going to give me, because it's individual, it's just going to return, I'll return nodes and edges. So let me get rid of all that. think that's right. Yep. There we go. All right. So I got a message of an error still. Expected name. Oh, am I supposed to pass? Yeah, I probably am. Let me see here. We got 1, 2, 3. That's 3. Oh yeah, I'm missing one curly brace right there. All right, let's see if that works. There we go. All right, so now I'm returning a new hope with, you know, the first four ships. But let's just try. I'm gonna try to do something kind of cool here. So we're gonna, let me go back into films. This kind of show. I'm gonna try to show some of the power of GraphQL. The stuff you just can't do with REST. So we got a Starship connection. Yeah, so I'm gonna get. So let's just do an ID here. So then starships can connect to pilots, for example. All right, we're gonna output the pilots for these ships. So let's output, I don't know, it's gonna output the first pilot. All right, so let's do this. It doesn't like, for some reason it's not giving me any. Oh, Death Star. Yeah, I guess that's not a good selection of ships. See if I can actually get a ship by ID or something like that. Let's see. Edges. All right, so we got film. Starship connection before, last, first. Well, let me just do all the ships in this one. So I want to see what we got. Doesn't like it if you have that. Expects if you have what is it, parentheses expects to get some kind of data into it. So if it's not there, it's not going to work. So we have. All right. So here we go. Let's see if I have any pilots. Darth Vader. So Darth Vader's TIE Fighter. Luke Skywalker. X-Wing. Okay, cool. So now, within pilots, let me just get down further than this. Pilots.
I have a question with the data structure there.
Mm-hmm.
I guess I'm trying to gain a better, mental model for it. So I'm not sure what the underlying data is like. Like, I'm not sure if it uses like a non-SQL or SQL. But I'm trying to develop a mental model for it. So
doesn't really matter.
It doesn't really matter. But in this case, would film be something like a table?
Yes.
And then you have something like Starship connection with like a form belonging to the Starship table.
Yeah, if you.
And then you keep drilling down.
Well.
Using foreign keys to connect to different edges.
You don't. Not necessarily. The way you do GraphQL, you just find a table. Doesn't matter if you have a foreign key. Can be no SQL. You don't have to worry about foreign keys. GraphQL, in its schema, defines relationships. So it will create relationships. So you could have a REST endpoint. You could have a relational table. You could have a NoSQL table, and you could make all of them have some relationship. Like you could have, for example, films in a SQL table, and then starships could be sitting in a NoSQL table, and you could say, you could define starships in the schema of GraphQL, and then point that to, like, you understand what ORM is? Object Relationship Model. So you create an object, basically, that represents each of these tables. And then you would define in these objects their relationship to other objects. So it would handle that relationship.
It's kind of like abstraction on top of all that.
Yes. So it doesn't matter what's underlying it. You can connect it all. That's part of the power of it.
Question about that?
Yep.
Does it store a cache
Yeah, it does store a cache. There's different ways of handling it, but it does build it out as a type of cache, depending on your server configuration in the back end, stuff like that. There's different things, but when the server generates the ORM, it does create a relationship in the server layer, not in the database layer.
Yeah, yeah. Do you define that schema? When you
Yes.
hire those services?
Yeah, I mean, it's different. Once again, there's different implementations. So depends on how you're implementing it, but programmatically or you write it yourself, the schema is defined one way or another. So you control the schema in one way or another. So you can say, I mean, you can even say like if you don't want access to certain fields, you can remove them, and no one will ever see them. It doesn't just automatically show up.
Right.
Or if you want to, this is only showing queries, but you can also do mutations, which is changing data. And you can say, I don't even want like these guys, they didn't include mutations. So you can just take that out of there and it won't show up. Can't do it. So, or if you want like certain users to be able to perform mutations and certain users not to, you can also define like a check and see, are they allowed to perform mutation? If not, then don't return mutations.
Is authorization part of the GraphQL spec?
You define it yourself or it depends on the service you're using. Some services have it built in, but authorization itself is not really defined. I mean, it's just you use it one way or another depending on what you're doing. There's a lot of different implementations of it, and they handle it differently.
Maybe one of the pieces that's missing is that in addition to defining your own schema, you define how everything's resolved. So like
Yes.
a certain object may be resolved by just one fetch out to some other API or something. Or maybe you have an individual field that's being resolved a completely different way, which means you could implement authorization on those resolved fields if you want to.
Yeah.
And you can get down to fine levels where you say maybe only certain fields are authorized by certain people.
Right. So there's like a plugin architecture that you can.
Kind of. I mean, they have
There's-
a directive architecture.
Yeah, well, there's three different parts. There's two different parts really. You're defining a schema, and you also define a resolver. Resolver says what the object resolves to, like does it resolve to a SQL table, does it resolve to no SQL table, does it resolve just a flat JSON file? Like, you could return whatever you want to return. You could just have it return one word, but it resolves to something, has to point to something, and the schema defines basically objects. It's not like really like a database schema. Like it's more object-oriented programming based, where strictly like each thing is an ID. You have to strictly say ID is an int, name is a string. Like it's strictly typed, and it's an object. An object can contain other objects. Like you could say users. Like you could have a user, and then a user could have purchases, and the purchases would be connected to a sales object, and so they have an array of all the sales that belongs to them, and then it would map that based on so it's you'd store the ID of the user one way or another. You would connect it up. It depends on what you're doing, but you'd obviously connect the user ID to the sale ID in some way.
Is each schema considered an API or an API gateway?
No. Well, you would, yeah. I mean, once again, there's different implementations, but you could actually take multiple schemas and some implementations and combine them all together as well into one. Some won't do that. Some will do that. It's
Like if I had two systems I wanted to serve an API to, and a user meant one thing to operations and another thing to a front end public service.
Well, you probably have to, if you're defining users differently, you would either have to have some kind of logic that says if it's this system, or use this schema, or you just use two different API.
You branch the schema as well.
Yeah, you could branch and modify it. I mean, setting up an API gateway like with AWS is very easy. So you could just literally set up two different gateways. It's not like that hard to do.
Cool.
If you can do one, you could do two. And you could do it pretty easily, but you could branch the code. Like if you want to have an internal and external API, for example, you might not want the external API to be able to do mutations, so you can just remove all the mutations from it, but it would still be the same code. It was just, mutations are gone. So you could set up even you could like set your code up to if, front end, just remove mutations or something. I don't know. There's just a lot of different ways to do it. And then any other questions about it? All right, so I'll get back to what I'm trying to show here. So what I'm trying to do is so we got the pilots, and then the pilots are a person. Person has data. Let's see. Person has a film connection. That's what I'm looking for. And now we want to get so I'm going to get all the films that the pilots are in. So we can basically we just want a whole circle, but that's what I'm trying to show here. No title. All right, so here we go. So we'll go down to, all right, so we got Millennium Falcon, and the pilot is Chewbacca here. So he's in A New Hope, Empire Strikes Back, Return of the Jedi, Revenge of the Sith, The Force Awakens. It's a little bit out of date, but so you can see here we went from film all the way back to film through a channel here. But you can now say, like, if you want to say you had, I mean, this is like Star Wars, you're probably never going to build an app for this, but a use case of this would be like, what if you had some kind of sales application doing business sales, and I'm just going to give 2 data points. You have employees and you have companies. And so you have Joe, and you want to return a list of everybody that works with Joe. So all you got to do is say, get Joe's company, now get all employees of that company. And so that's 3 parts, and that's it. Boom. You just got everybody that works with Joe. And this is a similar thing where I could say, like, give me the Millennium Falcon, now give me all the, give me a movie, A New Hope, now give me the ships from New Hope, now give me, the pilots, and I want to know what movies all the pilots of the ships of the New Hope are in. But obviously it's kind of a silly example, but you could come up with ways in which that could actually be useful in a some kind of production environment with certain kinds of data. Especially if you're doing some kind of data analysis or data mining, it allows you to easily connect a lot of data together. Mm-hmm.
Terminology for connections. Is there any reason why it has to be called connections? Could you? I mean, I know I've seen other APIs that don't specify connections. They just have, for example, Starship, and then the schema will just apply that it's an array, and then just return an array. Versus this connection. I know connections. I've seen connections as sort of like a relay thing, and Facebook uses it pretty heavily. But every other GraphQL endpoint, I guess GraphQL APIs that I've built with don't really use connections.
No, that's not. This is just this implementation. I would say, though, you need to stick with the node. I've seen also where people haven't even defined nodes and edges on it.
Yeah, I've seen that too.
But I highly recommend. The thing is, the way I'm building a service that basically can take any GraphQL endpoint as long as it's done through the correct specifications, and it'll just read it and output it in a format. Doesn't matter what it is. You can execute it and it'll work. You don't have to worry about like what, So if you use, instead of, like, you could call it ships and ship if you wanted. But the disadvantage of that is now, if you want to be able to, say you want to build a Star Wars database table and you just want to be able to do each query and see the data, maybe click on it, go down, it automatically does a query and gets the next set of data. If you don't use edges and nodes, you have to literally write the code for if it's a ship, blah, if it's this, like, it's just kind of waste of time. So, so as far as Starship connection, that's just a naming convention. That's not really going to, I don't know, doesn't do anything for anybody. But the edges and nodes, I definitely recommend keeping that, because as you go down, like even if you want to have some kind of recursive thing, like I've had a table builder that recursively will build tables. Like it says, if it's a edge, do one thing. If it's an object, do something else. If it's a value from key value pair, do something else. And so it recursively builds out data if it detects more edges. So because of that convention, it's easy to do, and it'll take any endpoint that's GraphQL that's done to this type of specification. Yeah, and when you're dealing with huge data, definitely you want it to be uniform. You don't want to be like, oh, let's custom name. We've got like one thing I have by one database we have is a smaller one, and I'm messing with it, and it's got like 31 tables. Like, so that's 31. Well, that's 62 queries. So you're going to custom name 62 queries, and then like how many mutations? Like 3, so it's got like 100 mutations. Like I don't really, it's just a waste of time custom naming all that stuff. For one thing, and then from the front end side, it's a waste of time having to know all that stuff.
I feel like a lot of this is done for you with, like in React, you would use something like Apollo or Relay. It would handle all the connection portion for you.
Yes.
But you still, like, I remember when you pull in an endpoint, you still have to loop over, or you have to make an array, or you have to loop over the edges, and then you loop over the edges and grab each node.
Yes.
Versus them just flattening it. I feel like if that's an abstraction, it should just be abstracted away by Apollo or Relay. Like, I don't need to know that this is a connection. I would rather just see just an array of starships.
Yeah, the one we're using where I work is a Python version of it, and it's called what is it? Graphene. We're actually not going to use it. We're switching off of it, but it never doesn't say connection. It does have some weird ways of naming stuff though. That's not really, and you can't easily control it because it's all based off of ORM, and so you don't even define the schema in that one, and so it's kind of a pain in the butt to deal with some things, but.
I think that's the direction of most GraphQL they're headed. Like the schema is generated before you base something in ORM.
Yeah, pretty much, except it is useful in some instances, like if you want to connect multiple data sets together, you still do need to have some kind of schema, or I don't know, you gotta have some way to connect them, which is in Apollo it's called stitching. In our case, we have a lot of different data sets, so we in some instances we do want to connect them together, some we don't, but it's more useful. It's also easier to keep the data kind of each database have its own separate schema, because then you don't want like a 10,000 line file when you got that much stuff going on. But yeah, it does allow you, and also allows you to automate. Like, see how I'm making this query here? You can actually, well, let me make a real query like you see in production first of all, just so you know what it actually looks like. So you have a variable which doesn't like it for some reason. Let me just get it written. I'll figure out why it's not working in a second.
I think the I has to be capitalized.
It does. Still complaining. Might not like that I'm only doing one. Let me see what it says. Oh, it's I capital D, I think. Hold on, let me go back to the beginning.
I think it's the type is an ID, not name.
Oh yeah. I'm used to the way we do it at work. All right, so now this is how you'd actually execute it, except usually you include everything. Let me just get back to the beginning. So you'd have film. This only has 2 things, but I've got some that literally have like 50 different parameters you could pass. So as you can imagine, having to sit here and type it all out when you have hundreds of queries and each one has 50 parameters could be a bit tedious. So, and it basically just mirrors each other. So you could, based on this, you could look at the schema and then write a program just to automatically build your queries, basically. And see, there you go, it works. And see down here, I'm passing a variable. So in your application, you just have to pass that object. And then I'll even look at, hold on, let me show you how it's done here. So we got, where's the GraphQL? I don't think it recorded it. All right, so I'm going to do that query again. All right. So, is this it? So down here, if you can see that, it says it's got query, And that's the query. Operation name, you get film, and it's got the variables, ID, blah, blah, blah. I don't know, can you guys see that? Yeah, I guess it's easier for you to see than me. All right, so that's what it's passing that in, right, as the parameters, and then it gets a response. I'm actually used to doing this in Chrome. Where the hell's a response? Yeah.
Oh, I think it's down there.
Oh, there we go.
Because it doesn't return HTML though?
No, it just returns JSON. Returns what you see here. That's what it's returning. Fine, whatever. Anyways, the response is this JSON object. So,
Can I ask a question about that?
yeah.
Does it typically come with libraries, or does it generate a client-side library that gives you a nicer way to access the data structure, or is it up to you to parse out your nodes and edges?
You would use, well, you'd use a library generally of some kind or another, but you get it in this, you do get the data in this format. You can use, there are like different clients, like there's an Apollo client, which will, are you familiar with Redux?
Yeah.
So it's similar to Redux. It'll literally, you do this query and it'll store it in a film. You don't have to implement it just does it all for you. Basically, it stores in a film reducer, but you don't have to write any code about it, and you can pull it out when you want it. And if it updates. Also, one thing GraphQL does is you can do what's called subscriptions. So if the data changes on the server, it pushes it out. It checks like what clients are logged into it basically, and it'll push the data out. And so Apollo will then collect that new data, and if they visit that page or whatever, it'll be there.
Is that a WebSocket?
Yeah, it uses a WebSocket. Yes.
That's cool.
Yeah. Yeah, there's different ways, whatever. I'm not going to get into how to implement that, but yeah, you can set up basically a WebSocket, and it has a subscription, and anytime something's updated, like you change it, you can implement however you want to notify people there's an update or not notify them or whatever, but it updates.
I just have a quick question about the syntax. So I'm confused how a node is in an edge. Like, I thought that an edge was like, one of those lines that's connecting the nodes.
Yes. Well, if you have a node, you can have multiple edges coming off a node,
Yeah.
and each of those edges goes to a new node.
Oh, okay. So when you say edges and then underneath node, you're saying that one of the nodes that is being connected to that edge.
Yes. So you have multiple edges, and each edge goes to one node. That's how you have to look at it. So, I mean, think of it as like a wheel where you have a center node and then spokes coming out, and you'd have edges around.
Oh, okay.
Or not edges, you'd have nodes around. And the edges, the spokes, go to them.
Each node. Okay.
Yes. And so you could have, you could have only one or 0 or 1,000,000 or whatever. But that node is connected to other nodes through edges.
Is it able to generate a visual representation of your data graph?
There's probably libraries and things that can do that. But, I mean, this is what you get here. But, yeah, I mean, you could build it yourself, or there's libraries. I mean, there's all kinds of visualization libraries. I'm sure you could just plug one in and do it. It's more, what it is the query language is like it defines how the data should look that's going to come back to you in a JSON format is what it's doing.
Okay, so the way you structure and nest that has nothing to do with the way it resolves.
The
No.
resolver is just tied, or how it's resolved is how you set up the resolver.
Yes.
For a field.
So your resolver could be select star from users. That's your resolver. And so it just gets all the user data. And then you'd have an ORM that maps that user, or you could also just map, you have an ORM that maps the user, and then that model is connected to a GraphQL schema of a user, so they're interlocked. So anything done to that GraphQL schema is done to that model. That model is connected to your SQL database through a resolver of select star from user, and then that, I mean, you're using a library. If you're using ORM, you're using a library, and that library knows, oh, users, if we update username, then execute this SQL query to update username.
Do you have an example of any chance? For example, of the implementation for this API, the resolvers and all that?
Yeah, I don't have an example of that. I mean, it can get pretty complicated pretty quickly, but let me see. I have an example of some resolvers to a NoSQL database, which I could. Yeah, I don't remember what I even have in this thing, so we'll find out in a second. Oh, good. Yes, so this thing does have resolvers in it. This is a AWS implementation, but it auto-generates resolvers and stuff for you from the command line. So you have, let me get down here into this. So first of all, we have a schema, GraphQL schema right here. And this has, this is like an online market, right? So it has a market type, and has ID, has name, and then has products. And a product is connected to another model. Unfortunately, the screen gets narrowed on here. It's hard to read. But anyways, it's connected to this product model down here. So it's saying products is this product model. Tags is an array of strings. Owner is a string. And then you got to create it at time. This is using NoSQL tables. And then we got, and this is the product. It's not connected to anything. We have a user. The user is connected to orders. And here's an order type down here. And order here is connected to the shipping address, which is just, yeah, so there's a lot of different connections. So then if you go into resolvers here, which this is AWS's system, so it's probably not totally what you're used to because they do their own stuff. But here's, it says, this is a NoSQL query to it. So it's saying, what am I getting? Oh, products. Yeah, it's pretty complicated compared to SQL. But yeah, you got, this is the resolver basically. It's defining how to get the data from that table. So it's saying, where's the damn table? So there's query right here. Connect. So it's connecting by product market ID, and then it's returning, looks like the context source ID. So it's just returning the ID of that market in this case, or the products connected to that market. And there's a lot. These are all resolvers here. So there's a lot of them.
So this is generated from a CLI?
Yes. From Amplify CLI, which I forget the exact thing, but yeah. Let me see if I can. See if I can get it to output something here.
One thing that's pretty cool too is like if you look at his schema, right? Like let's just pretend like I'm a front end engineer, right? And that's all I do. But I obviously haven't seen what he's doing over here. But if he passed that schema off to me, I know exactly how to use everything he's doing in GraphQL. I know exactly how to mock it. Like I don't need to know how the data gets there. And he'll figure out how the data gets there through resolvers, which is really nice that has that separation too.
Yeah. Yeah, you don't need to, if you're not doing the back end, I mean, this is all you need to know. Even then, yeah, implementations in the back end are very different. There's some things that'll take care of a lot of it for you. I mean, depends on what back end language you're comfortable with and that kind of stuff. So there's just a lot of different options. But if you're only doing front end, literally all you need to know is, okay, this is basically, I'm defining the definition of the data I want returned. Here's the data that's returned, and I can get the schema, and this is all the documentation you need. You just got to get used to writing the queries, which doesn't take that long. It's not that difficult to do. And so then you say, oh, I want to get all films. Let's see. So here's the variables I can pass in. Here's the possible stuff that I can return. And, you know, what can I return as a node? Oh, here's all the node stuff. Oh, look, it's connected to species, starships, vehicles, characters, planets. So I can pull additional data from any of those.
And all of those annotations there too, like the comments, those are just comments on that schema file. Like we don't have access to this one particularly the Star Wars one, but if you were to look at the schema file, it would literally just have comments like that.
Yeah.
And
Yeah.
with the special, it's like a triple quote mark, or like 3 double quote marks. And you can put markdown in there, so you can basically mark up all of your documentation, just mark down right in the file.
Yeah.
That's cool.
Yeah, exactly. And you could, yeah, see, allows for people to quickly know what it is, especially if you're doing an external facing API. People might not understand like what's the difference between a blah ID and another ID, or whatever. You want people to know, especially that kind of stuff. Or if you have a lot of data, you might want to define it so people know what you're doing. Yeah, so that's pretty much it. I'm trying to think of anything else to cover. There's a lot to GraphQL. It allows you a lot of freedom as a developer on the front end too. And as well, it allows more freedom on the back end, because the back end developer now doesn't have to like create, the front end doesn't go, oh, we need this special data, and the back end's got to constantly build new REST endpoints. You can get whatever you need as a front end person. You don't have to ask anything. It allows kind of more freedom on both sides of the of that operation. And then it also, you're separating these components more, where the back and the front end don't necessarily have to be as tightly knitted together. The back end can do whatever they want. They could change the database. They could take everything from NoSQL and put it in MySQL, and the front end people never know. Like, you're not even remotely connected to them and what they're doing. So just a lot, and the front end people could change the interface, and the back end people don't have to do a single thing. So it just allows more freedom from each team and each environment and that kind of stuff. As well as you can build this, you can actually automate this, because you're building schemas based off of your databases. So you could set up an automated process and just boom, pop out a bunch of APIs really quickly, and that's it. All you got to do then is maintain an automated process.
Let's look at like schemas. Kind of a little more familiar with like Swagger.
Yeah.
Something similar to kind of define a schema that's within a bunch of code.
Yeah.
That's super handy.
Yes. Well, yeah, it's more declarative. If you can be more declarative, then it makes it easier, because it represents what you're going to get, basically. And this is a very declarative query language, where like the JSON matches the format of the query, basically, almost exactly. There's not really a lot of question of what you're going to get, whereas like you get into SQL, you can get some pretty ugly queries pretty quickly once you get into complicated data connections. Like something like this, where you get the data and go drill down and get back to it. A SQL query that does that, like, I don't think you want to even mess with that.
They had some friends that they were database people, and they would like have queries. They were working for large companies, and this SQL query would literally be like a couple of pages long.
Yeah.
Like all sorts of messy stuff. Just can't imagine the insanity of that.
Well, the thing is with this, it's even, I don't know if you're familiar with like functional programming, but even like on the back end, it's going to be more functional based, where it's going to string together, and it'll create a query basically off of the resolvers you have. So it's not as bad, because it's like a functional way of doing it, where you're stringing together parts. And you don't even have to do it. Like once you create the resolver, it's like, oh, take this and do this and do this and do this.
Pieces and trying to combine different things together.
Yeah, exactly. Yeah.
So now, do the resolvers, do they do anything special to get the data out more efficiently? Joins or anything like that, or is it just grabbing this record, then it's grabbing the relationships over here, so it could be doing multiple queries versus, say, a database admin who will lump it all into one query and grab all the data at one
All
time?
right. It depends on your implementation. I can't really say totally on that.
Yeah.
I think most of them, if they're using ORM, it's just going to map that to the ORM, and obviously not going to pull the data in, but it's going to have it all mapped to that
Yeah.
ORM, and however that ORM handles it, how they implement it, is what you're going to do. Like, I don't really know. I've never really looked into ORMs and said, oh, how exactly are they getting the data? I mean, if it works, I don't really care.
I have a pretty strong background in database management, so that's why when I do deal with like Ruby on Rails, I get frustrated at how many queries it does, because I'm thinking I can do all that in one query.
Oh, yeah.
I could totally speed this up. Like, this is stupid. It's just did 6 queries. I can do that in one.
Well,
grab
one-
all my data, and it's. But yeah, I see. I'm not saying this is a bad idea. Just trying to get an idea of how exactly how it works in the back end, because
Depends on your implementation.
Yeah.
I mean, if you're using Python, if you're using JavaScript, if you're using
one's a little
C
different.
Sharp, they're all going to be different in the way they handle it, first of all.
Okay.
Second of all, it does actually reduce the number of queries, because now, say, like with REST endpoints, you might need to do 5 REST calls to get all the data you need. But
Yeah,
here you
but-
can exactly define what you need, so it's just done at one
Yeah.
time. I mean, it's pretty fast. I have one running. It's running on AWS through API Gateway, running on a Lambda, and I'm getting like 100 milliseconds return time from everything I do.
Mhm.
I have limitations because of the Lambda, where I can't return more than 4 megabytes of data.
Yeah.
So I limit the data I get back, but it's fast.
Yeah.
Like it's, and yeah, I don't know. Like I said, we're using Python, and I think SQLize is pretty good. We're using SQLize as the ORM,
Mhm.
not SQLize, SQL Alchemy
Okay.
as the ORM. So whatever SQL Alchemy does is what it's doing. And as far as I know, it's a very good ORM. In JavaScript, you have SQLize, you have Mongoose.
Mhm.
If you're using AWS, you have Dynamoose, I think it's called.
Yeah.
So just depend.
It's
You're
gonna be a little bit different.
yeah, you're at the mercy really of the
Yeah.
designers of the ORM at that point. It's not.
So the ORMs allow you to do raw queries. So if you like really know what you're doing, you
Yeah,
could
yeah.
actually write a raw query.
Yeah,
and
you
that
just
ORM has that code.
there's some really like stupid things that at least Ruby on Rails does that drives me crazy. Because if you like a good example is if you're gonna pull out 20 records and you want to you know you're gonna loop through those records, but you also want to count and you want if it exists, it'll look to see if a record exists, and then it'll do a count to count how many records it's gonna get. Then it'll grab the 20 records you want or whatever. Well, those just did 3 queries, where you really just wanted to grab the 20 records and count them and get the first one, not 3 queries. You should have been able to do that in one. There's no reason to do 3.
Yeah.
So there's certain things like that, and I think, I don't know about other ORMs. I've only used a couple different ones, but Ruby's the most recent one that I've been using. So, and that's just trying to figure out, looking at logs, going, why is it doing
Well,
27 queries for
I know-
loading this one page?
I know a lot of companies are moving away from Ruby, so I assume that's part of the reason why.
Yeah, I'm sure.
There's other ones. I mean, Node's taking over. I know C# is actually supposed to be the fastest.
Mhm.
So if you're looking for speed, they probably are very efficient, and
Yeah.
that one's probably the most efficient one. But Python's pretty quick. Node's pretty quick. What else do they support? Java is supported. You can do anything.
Yeah, it's just trying to get the boss to. He's all into the Rails thing because it's easy for him.
Yeah.
Because it's stupid easy. A monkey can do it.
Yeah.
It's like you just like go in and run a couple of commands and boom, it generates stuff, and you just migrate, do this, do that, and then next thing you know, you have this gigantic mess.
Yeah, I've never used Ruby on Rails, so I can't comment on that one.
If you
But
have people who aren't really like programmers doing it, then it turns into an enormous mess.
I think that's
'Cause
true.
It's too easy for them to just, I need this. Let's
Yeah.
generate it, because it's just got generators, so it generates the models and everything else. The next thing you know, you're like scratching your head going, why in the world?
Well, I've seen things turn into messes that have programmers involved too. So.
Oh yeah. Well, you can do it with any language. You just
Yeah.
Ruby on Rails is just real easy to just do things that you're like, for like I wouldn't consider him a beginner programmer, but he's definitely not deep into it like a lot of us are.
Yeah.
We dig in and we find out the best ways of doing things. He's just like, generate it. You're like, dude.
Yeah. No, yeah, I understand that. But yeah, I can't. I mean, every ORM's different,
Yeah.
and I honestly haven't dug into any of them to know enough about
But you
it.
never ran into performance issues with your work with having such an enormous database or anything like that?
It's fast.
It's fast always.
The issues I have is I'm running on a Lambda. I'm limited in. First of all, the Lambda goes to sleep if you're not using it, so it takes time to spool up. So it can take a second or two on the very first query,
Yeah.
and then I try to hit something that's bigger than 4 megabytes. Obviously, I can't do it.
Yeah.
Like if I try to we'll return all our trademark records, like millions and millions of records. It just says server error. So, it just doesn't work.
I need to do the Lambda thing. I have not got into those yet.
Yeah, it's pretty useful. I mean, you can do. We're also moving into Docker containerization and stuff like that too,
Yeah.
which is also.
I've been transitioning to Docker for all my development because
Yeah.
it's so much more convenient to not have to do all the different jumping through hoops. Every time I upgrade my Linux box and like Node changes, and then Heroku changes, and then the boss changes, and everybody's got different versions of Node, and then it wants to reject it, and
Yeah.
yeah, so the Docker thing is something it's making my life a lot easier.
Oh yeah, for sure.
Even this Java program I'm messing with, I'm working on getting into the Docker thing, and yeah, a little bit more difficult than the Node and stuff, but
Yep.
fun stuff.
Exactly. Well, yeah, we're using it pretty heavy for some legacy systems that are difficult to deal with.
It's great to have that container without having the virtualization.
Yes.
Because I used to use VirtualBox to
Oh
kind
yeah.
of segment out things out, you know.
Yeah.
And it was like I got all these different virtual machines running for databases and different things, and yeah, kind of a nightmare to deal with, and they're large.
Yeah.
You know, take up a lot of space.
Yeah. Of course, I've dealt with that. It's a nightmare. Pain in the butt.
Mm-hmm.
Cool. So, any questions?
How would you suggest like implementing that with like a React app?
What part? What do you mean?
I mean, all I know is how to use Mongoose to communicate with MongoDB.
Yeah.
So how would I use this in an app as opposed to Mongoose
All right.
or MongoDB?
So you would go in to your Node server, and there's videos online and stuff how to set it up, but you'd probably use Apollo is one of the top ones for React, or not for React, for Node. Use Apollo. Go through a tutorial on how to do it, because I'm not going to explain it to you in depth here, and you wouldn't remember if I did anyways. And then, yeah, just follow the tutorial. If you're already using Mongoose, you're basically just going to map that ORM to the GraphQL, and that's pretty much it. And then you have to set it. Obviously, Node has to be. Probably already have endpoints for Node, right? You're probably using REST, right? So I think GraphQL only runs. I forget if it's put or post, but it only runs on one of those two. I think it's put. So you just always hit put. And then on the front end, there's different clients you can use. You can use Apollo client, or if you want to go super simple, you can use like Amplify, AWS. There's a bunch of them. But you can use AWS Amplify, and there's AWS. So you have I think API.GraphQL, which will execute GraphQL queries. You just gotta read a little bit on how to do it. The front end's pretty easy once you understand the basics. I think Apollo client's a little more complicated, but it's a lot more powerful. So at first, it's probably gonna be a little harder to use, but as you use it more, it basically replaces Redux. So you gotta set the whole thing up so you can do that. Whereas like the AWS Amplify library, it just allows you to execute queries wherever you want and return the data. So, I mean, it depends how you want to do it. Because I'm using the app I'm working on, I do have a lot of Redux stuff in there too. So and there's some issues with the Python implementation, so I'm having to connect to multiple GraphQL APIs, and Apollo won't let you do that. So I'm having to use AWS library right now to do that. But if you use Apollo, it is better. But yeah, like I said, it's more complicated. And it just depends on your implementation and things like that. But yeah, but you can play around. First thing is just build a backend server, basically. And then you can set up, once you build a backend server, you can actually, there's a library for graphical. And so you can just create a graphical page. And then you can hit the endpoint and see how it all works. I have a page for it where I can hit all the endpoints and get the data before I actually build it. And that's how I do it. But you're going to have to tweak with CSS a little. For some reason, it's like, when you first load the graphical page in React, like the height is set to 0. So you have to set the height to like 1200 pixels or something like that so you can actually see it. Otherwise, it's just a blank page. It took me a while to figure that out. I don't know. I started Googling. I was like, it's not showing up. So I just started Googling. And they're like, oh, the height is not set up. You got to adjust your CSS. And you got to import a whole CSS file and blah, blah, blah. Anyway, so it's not hard to do. It's just a little unexpected.
I saw a video where they served up the graphical just on their local host, super easy, like with.
Yeah, you can also serve it on the server side. Yes.
Oh, okay, gotcha.
Yeah.
Yeah, if you use
Yeah.
Apollo, like, you know how, showing me that there's really only one endpoint?
Yeah.
Yeah.
Apollo sets up an optional second endpoint, which is like Playground or something like that.
Oh yeah. Yeah, that's right. If you're just doing it local.
Probably saw
Problem I have is I'm doing a Python implementation. It's running on a Lambda, so I can't just do that. So I have to do it. I have it built into the dev environment of our application because it's impossible. Like I can't. I'm not running it locally. It's on a server,
Yeah, gotcha.
so I can't do that. But yeah, I forgot you can do that with Apollo. Just go into like playground mode and you can mess around with it all you want. Yeah, and then once you get a good handle, I guess, on queries and mutations, see how they work, what they do, then you can start implementing in your application. And I would recommend there's a lot of courses and stuff on Udemy and YouTube videos and things like that. I would just check out. Yeah.
Do you use directives at all at your work? Like the directive syntax in your schema?
You're talking about like underscore?
No, like it's like the at symbol next to like fields and stuff. So
Oh yeah, no, that's used. AppSync uses that, but with SQLize, you don't touch the schema; it auto generates it from the ORM, so we can't even do anything with it. Yeah, you cannot even touch the schema.
we do that a lot with our stuff because one for authorization, like somebody mentioned, and then another one for like
Yeah.
they're like on internal network stuff. And it's obviously something that's
Yeah.
so we provide more usually like products and stuff on the site.
Yeah.
And it was like as easy as writing like basically an authorization directive and an internal directive and then just slapping like at internal or at authorized on the fields you want to clear. It was pretty sweet.
Yeah, I know AppSync does that. AWS version. They use directives a lot. When we switch to Apollo, we'll probably have that too. Yeah, and we're definitely going to be limiting users. Different types of users can do different things, but it's also based off of, we got a whole like federated identity management for the whole company, and it's a lot more complicated
Yeah.
than that. I mean, we've got like 10,000 employees in the U.S. alone. So, yeah. What's that?
It's definitely a lot to think about.
Yes. We got more employees than many people get website visits in a month. So, yeah. But any other questions? All right, cool. So I guess I'll end off here.